few areas that I want to look over and practice, starting with the expression for which your expansion is valid, remembering that you only need to consider the x term as long as your other term is 1, and how this part needs to be less than or equal to 1, otherwise your expansion won't converge to a particular value. And you can rearrange that by simply balancing it out and recognizing that these two things are the same. You shouldn't have two terms in here. It should always start off with your, again, x term here. Remembering the formula, you're given 4, 1 plus ax, and you're always given this is going to be valued for expansion, so your x value is less than 1 here. Similar through here, look at this part here. When you are trying to manipulate your expression so that it's in the form for which you can apply your expansion, it needs to be 1 plus your x term. So careful when you're factoring out, keep your power in place, and then you can use the index laws to distribute your power and then manipulate it here. And then you get this. Make sure you're reading the questions very carefully as to the number of decimal places. With this one where you're trying to make an approximation for a particular value, when you substitute the value you've got, notice you can actually get to the value that they require by splitting this up into two separate terms being multiplied. So the factor of one of these is going to be what you require, your fifth root of 29, and then you can rearrange that simply by multiplying by 2 for what you need. So if I know that this is half times that, then the fifth root of 21 is going to be 2 times my expansion when my x value is 1 over root 32. Here, somehow you manage to get right answer, cross it out, and then put the wrong answer here. Check your expansions carefully. If need be, use a grid or whatever it may be to separate your working out. Use enough space as you need. Often a grid is helpful to not confuse things when you're adding or multiplying. Checking where there's going to be more than one expression expanded, looking at both expressions for which your expansion is valid, and taking the inner one which encompasses both. Here again, I think you just need to be careful with your values expanding. Once more, when we expand this through, we actually can split this up and see the root 17 which we require, and the expansion gives us a quarter times root 17, so we can just take our final answer of expansion given x is going to be 0.0.1 and multiply the final answer by 4 to get what is required. I really want you looking over this and practicing this. Your partial fractions was fine, but there's this element here which is not quite right. This manipulation you've applied here, I'm not sure where it's come from, but make sure you're doing this correctly. Again, color coding if it needs be for the last part. Hopefully if you got this part right, you would have got the next part right, because it's just addition, but this should not be a mistake you're making.